Hello. Discussion today is about combining and separating roots. A lot of times it's also called simplifying the square root, but in our case, you can almost think about more of dealing with combining and removing in terms of multiplication and division because it is the exact same procedure. Again, I'm not a big fan of memorizing tons and tons of the procedures. But if you know one or two procedures and you can use that in different ways, it's one less thing you have to memorize on how to do these problems. And to give an example, let's say you have a simple problem that looks like square root of 2 times square root of 18. Now, you can try to simplify each of these separately. A lot of times, though, it's easier since you're multiplying to combine these two and then see if you can separate them afterwards. So we combine them by doing 2 times 18 under 1 square root. Since we're multiplying here, we can combine the two and multiply and then do the power afterwards. So in this case, we'll have square root of 36, which is 6. This is similar if you have 2 squared times 3 squared. You combine under one thing because remember, roots are just powers, or just exponents. So you have, in this case, 2 times 3 squared, 2 times 3 being 6 squared, or in this case, 36. So this works really, if you think about it, this is almost a reverse factoring. If you wanted to factor, let's say, a larger exponent, or a larger root, I should say. After all, roots are exponents, after all. So if you had something that looked like one of the more famous ones, let's say square root of 18, and you want to simplify that, well, first you have to ask yourself, can you factor this into two separate square roots? And to do that, you have to think, well, is there any perfect squares less than 18 that you can multiply into 18 here? Well, your first one is 4, because square root of 4 is 2. Well, does 4 go into 18? Not in this case. So we go with the next one up. Square root of 9 is 3. Now, 9 and 18. 9 is a factor of 18 because you get 9 times 2 is 18. So you could rewrite this actually as 9 times 2 to give us 18. Similar when we multiply two things, combining them to make that 36 in that last bit. Rewind if you have to. This time we can actually combine these two. This is just reversing what we did earlier. Notice it's the same procedure. So in this case, we want to do that. We can do this before we combine. This time we're separating, but it's the same idea, same rules that you're using. So you're going to find out what the square root of 9 is. Now, we wrote that down here as 3, which is true, but let's say you didn't know that, then you would have to figure it out or find it in the table or try to remember it. So I give you 3 square root of 2. Now, the question is, can 2 be reduced down any further? In this case, no. How do you know this? Well, factors of 2. The only factors of 2 out there are 1 and 2. Again, and that's not really helping us because we're not really changing what's underneath the square root here. So that's how we know that we're basically done with this problem. Which I know is a big problem for a lot of people. It's like, how do I know when I'm done? I'm trying to do this problem. I'm trying to get this combined. And I never know when I'm done with the problem. Well, when you're doing with simplifying roots like this, you know when you're done because you say, can I factor what's underneath the square root anymore? If you can't factor what's underneath the square root anymore, then in that case, you're done. And how do you know when you're done or not? If you can or cannot factor, it's something you're going to have to get used to and memorize. Or at least, unfortunately, this is something that's true with math a lot. You have to basically do the problems enough to know when you do it. So it's experience. How do you get experience? You actually do the work. So unfortunately, this is not an easy way out. But most of the time, math isn't overly easy. Now, if we want to go something a little bit, same idea, we want to simplify that square root of 200. Now, we have to ask ourselves, perfect squares of that factor, that can factor to give us 200. Well, our smallest perfect square is 4. And it's true that 4 times 50 is 200, so that could work. We also have to ask ourselves, is there anything bigger we could use? Well, again, this comes with experience, but if you think about it, this is 2 times 100. 100 is 10 squared. So really, you could say this, you can rewrite it as 100 times 2, and then take the square root of each of these individually. So you got a square root of 100, which is 10. Again, square root of 2, you really can't simplify. It's approximately 1.141, going on and on and on and on, but it's approximately 1.4. When it comes to knowing the square roots, yes, it is irrational, so you don't get a nice round number, but just having an approximation that is around 1.4 will help out tremendously in terms of if you have to graph the number or just getting a feel for what these numbers actually are. Now the other thing is that this does not go with the square root. You can also do a cube root. So let's say I have a cube root here of 81. Now if that was square root, that'd be easy. 9. Square root of 81 is 9, or 9 times 9 is 81. In this case, though, it's a cube root. So something times something times something. Well, we know 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, so it doesn't work out. But, so we know 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So we have to think, can we factor 81 using one of these here? Well, obviously 125 doesn't help because it's bigger. 64 times 2 is 128, so that definitely can't help us out there. So we're down between these two. Well, think about your factors of 8. 8 times 10 is 80. That's 81. So that's not going to help. So if there is help available, it will come here. Now, will it work? Won't it work? Stay tuned till later. But the thing is, it doesn't always have to work out. If I had 82 here, you can't simplify it any more than that. If I had 80, you couldn't simplify it more. Now, will 81 work? Well, think about, you can either do 81 divided by 27, or you can do your factors of 27. So 27 is your first one. 27 times 2 is 54. And 27 times 3, we just kind of add on here, because we got 27 there, 1, is 81. So this is actually 27 times 3 cube root. Notice the dot there, right? There, notice the dot. Okay, so we're going to do cube root 27 times cube root of 3. Now, cube root of 27 is 3 times the cube root of 3. Now, admittedly, there's a lot of 3's there, because you have your 3 times cube root of 3. But there's nothing wrong with having that. And it makes sense. If you think about, you have 3 times cube root of 3. And that's 2 with the cube root, the 4th roots, the 5th roots, 7th roots, even though you won't really want to see 7th root in introductory mathematics. But if you get higher and higher, you will see it. Now, so far we've been dealing with numbers, which is all great and well and good. After all, you do have to deal with numbers, but this is algebra. And what separates, in my mind, arithmetic from algebra is algebra brings in the variables. Luckily, the variables are actually easier than the numbers. Yes, it's true. I'll give you an example. Let's say you have the square root of x to the 4th. Now, if that was a number, you have to think, well, is that number a perfect square? If it isn't a perfect square, is there a factor of a perfect square involved? Here, it's so much easier. 2 different ways to look at it. I'll show you both ways. They're both about equal. It's a matter of what works for you. Again, you pick what works for you. If something doesn't work for you, don't do it. If there's an alternative way, use the alternative way. In this case, if you see a square root, notice that, remember, there's not a 2 out here, so it's a square root, or a 2 power. You divide your power by half to take the square root. And you're done. Now, the other way to think about it is, remember, square roots look like that. There's a 2 out there. And remember, that's a fractional exponent. If you don't know about fractional exponents, I do have a video about that. Review that. But knowing that, they can rewrite that as x to the 4th to the 1/2 power. Now, if you think back to when you first learned about exponents, if you have a power raised to a power, you multiply them together. So in this case, this is x 4th times 1/2. 4 times 1/2 gives us x squared. Now, admittedly, longer way, shorter way. This creates a lot more memorization. This gives you a method you already should be familiar with. Now, this is all well and good. I mean, after all, if you have x to the 18th square root, that's x to the 9th. Again, divide by 2 because you have a 2 power out here. This actually makes the higher powers even easier. Because let's say you have a cube root of x to the 9th. Well, remember how we divide by 2 because there was a 2 out in front? We have a 3 out in front. So we divide by 3, exactly. So 9 divided by 3, x cubed. If you have the cube root of x to the 18th, well, it's 18 divided by 3, or x to the 6th. So this is all pretty straightforward if you divide out evenly. Okay, let's say you have the square root, we'll go back to square root, of x to the 5th. Well, that's 5/2, or 2.5. Now, the other way you think about it is, remember how we were dealing with numbers? You had to separate them out, factor them, do each of them separately? Same thing here. Thing is, when you have an even power, a square out here, which remember, there's a square out there if there's not a number, and you erase, it's a square too. So, we have to convert that x to the 5th into x to the something times x to the something, and the first thing has to be a factor of 2. Well, factors of 2 are just even numbers. So we can say that's x to the 4th times x. Okay, so this is now an even power, which we can do a square root of very easily. And that we can just leave alone. So x to the 4th, the square root of that, will just give us x squared. Remember, divide by 2 there. Times square root of x. Now, if you also think about that other way I talked about, converting it to a x to the 5/2 here. Well, like I said, that's x to the 2 and 1/2. Well, there's your x squared. And x to the 1/2 power is just the square root. So these are two different ways. You can either think about it as factoring, do it that way, or think about dealing with the powers and doing it that way. It's really what's much more comfortable for you as a student. The same thing with the cube root. You have to, let's say if we have the cube root of x to the 13th, well, you got to break that up. Well, factors, the cube root is 3, so factors of 3, 6, 9, 12, 15. Well, 12 is the closest thing there, so you get x to the 12th times x. So that'd be x to the 4th cube root of x. Now be careful when you're writing. I'm kind of mushing it in here because I'm trying to get it close and I'm running out of space. But if you're doing this with a piece of paper, and assuming you have enough room to do it, give yourself enough room. The one thing you don't want to do is make the instructor play hide and guess and seek. I've had students where people put it in, I had to turn it that way and turn it that way and move it back this way in the same problem. Does not make a happy instructor. You want the instructor to be happy if all possible. It really helps out when you're trying to do things. So far we've dealt with numbers, we dealt with variables, and now we have to deal with numbers whilst and at the same time. To give an example, square root 12 a cubed b squared. Now, you think I've got 3 things there, one at a time. Since we're multiplying, we can do one at a time. So look at your number first. Can't we take the square root of 12? Well, let's think about our perfect squares again. 4, square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. It doesn't match, but notice I said 4 there. So I can change this as 4 times 3. Remember, we're still under that big old square root. Perfectly fine there. Then a cubed. Then a cubed, we can say, well, that is not even power. So we cannot take the square root of it just by going into half. But we can make that into an a squared times a. So we can at least pull a good amount of it out. And that's b squared. Since that's an even power, we're not going to do anything with it. Notice this first step, all I did was factor. I didn't pull anything out. I just factored. One step at a time. Remember, you cannot multitask. It is impossible for a human being to multitask. You think you can multitask, but all you're doing is quick switching. In other words, you're switching between procedures very, very quickly. You don't want to do that. So if we can only do one step, not only just one step at a time, but one procedure at a time, it makes things easier on you. Now we're going to take the square root of everything individually. Square root of 4 is 2. I'm going to put a square root symbol here. Square root of 3 is 1.7 approximately, so it doesn't come out as an integer, so we can't pull it out. A squared, well, that becomes an a. Remember, square root of a squared is a. We divide our power by 2. A by itself we can't do anything with. And b squared, square root of that is just b. So this can simplify down to here. Now, you're looking at that and thinking, that's a lot simpler in terms of the amount of writing, because you have some on the inside, some on the outside, you have your numbers. What's considered simplify is basically looking at a square root and taking out everything you can while you can in terms of that square root. If you have questions that I did not cover on simplifying radicals, simplifying the square root, the cube root, whatever, post it down in the feedback. I'll answer it. Check out my other videos. I may cover it there instead. Thanks so much, and good luck.